when talking about microgeographies and inequality. Next time I will start at this part of the room with questions. So second keynote of today, I think he doesn't need a lot of introduction because basically Lee Fleming is a name that influenced a generation of innovation scholars in a way, I would say. His work on knowledge spillovers, inventor mobility, networks, all of it was very influential also for this conference and this community. So I'm very happy you could make it, Lee, to Budapest this time. And you also worked a lot actually on patent record disambiguation, on creation of new data sets. So I'm very curious to learn also how you will revisit Marshall today. So welcome with me together, Lee Fleming.
Thank you so much. Okay, lots to hold here. So, yeah, excellent. Thank you so much. Thank you to the organizers, for the session, to both follows. Those of you that have put on a conference like this know just how much work it is. And we all show up and it's great fun. There is so much effort behind the scenes, and I want to express appreciation for that. Thank you. Secondly, kudos to organizers. This is a fantastic pairing of plenaries. Louisa did a wonderful job of describing the micro mechanisms. I'm going to move up a level of analysis, but all of my theory, all of our models depend upon this rich ethnographic description, and you really do have to use both. And people don't realize this, but I was actually trained as an ethnographer, so I have a huge appreciation for that. It's super important. Okay, and finally, I'm going to violate the most important rule of presentations. I'm going to stuff 4 papers into the next 35 minutes. I apologize for that. There's not going to be much time for questions. Please drop a note, lfleming@berkeley.edu with criticisms. So, okay. Yes, thank you again. And it's the first time Candace and I have been in Budapest, and it's just spectacular. I walk along this riverfront, and I almost want to play hooky and ditch the conference and go see all the castles. So it's really, really beautiful here. So I hope he's looking down upon us today. Our founding saint, Alfred Marshall, 1890. If there had been a Nobel Prize back then, he surely would have gotten one. We're beginning to put together the evidence that he was indeed mostly right. It's very impressive that he could foresee so many predictions and so much theory. And now we can start to go further. And that's where I'm going to talk today. Okay, I'm going to try to get through 2 streams of work. The first one, a brief digression for 2 simple papers, short pieces, a causal knowledge of model spillovers, and then the main attraction. And again, to Louise's point, this is a wonderful crowd because regional economics and strategy. It's going to be a marriage of those 2 things. I'm going to take Marshall's ideas of localized knowledge spillovers and try to find some causal evidence for absorptive capacity. And then some very recent work. I think it's very interesting, exciting stuff, building on Enrico Moretti's paper. I know that paper's been maligned a bit, but we're going to try we're going to confirm some of the aspects of that paper and move on to some new stuff as well. So the takeaways from the first stream: novel causal model of knowledge spillovers. We're going to apply it to sort of the most important strategy paper of the past 40 years. We're going to look at one very narrow mechanism of absorptive capacity. We're going to measure the absorptive capacity ahead of time, and then we're going to exploit an exogenous change in the availability of that knowledge. The results, we're going to confirm Alfred Marshall. We're going to talk about some mechanisms. Those are fairly old, and we're going to see that within firm spillovers do not localize. I won't spend time with this crowd. The workhorse model in our field, the Jaffe, Trautenberg, Henderson knowledge spillover model, we're not going to use matching. We're going to be estimating the effect within the same patent or the same science paper. So there's no need to get into the problems of matching as Peter Thompson has laid out. So, okay, so here's the brief digression. Two short pieces. This is firmly in the regional economics literature. So this is Ben Baltzmeyer. He was visiting me last 10, 12 years ago. This identification strategy is Ben's. It's quite clever, I think. He came to me one day and he said, so I'm looking at the inventors here, and it says deceased up in the description of the inventor. He's like, what's going on here? Well, I don't know. But there were a couple thousand of these and in the time period. And what happens is an inventor applies for a patent, and then he or she dies before the patent is granted. So in this interim patent pendency period, you have somebody dying. And some of these are actually, or many of them are young, probably more unexpected. And we'll use that as an exogenous change in the source of interpersonal knowledge spillovers. That's the key to this identification strategy. So we're going to take only the patents that have somebody dying in one town and they have a co-author in another town. And we're going to estimate the citations in these two regions to the exact same patent, but in the two different regions. We're going to basically count up, the simple model is going to be a Poisson count model. We're going to count up the citations in these two regions and compare them. So here's a picture. Peter Thompson was a discussant on this at Rear at Georgia Tech. Here's a patent, same patent, and we've got Daniel Loon, who lived in Boston, and you have his co-author who lived in Silicon Valley. As Peter Thompson pointed out, Daniel Loon was one of the first counterattackers in the 9/11 attack. He was on one of the planes. So we didn't realize that, and Peter found that. So essentially what we're going to do here is we're going to take radii of the same size, same geographical size, take concentric rings of radii, and we're going to compare the citations in Boston to the citations in Silicon Valley. If you get that, you can go to sleep for the next 25 minutes. That's the guts of what we're going to do. So you see those concentric rings will be the x-axis here. We're going to keep estimating larger and larger concentric rings, and that will give us an estimate of a knowledge spillover. And it's a citation. We're basically, remember, comparing the citations in Boston versus the citations in California. And what you see here, you're going to see this is a decrease of Boston relative to California, and you're going to see that becomes much, much less as the distance increases. And remember, this is the same pattern. There's no matching. Okay, we're going to take Pierre's science data set and do the same thing, and we're going to get very similar results. So Pierre Azoulay has this data set of eminent biomedical and biotechnology scientists. You've got an unexpected death in one region, and you have a living co-author who stays alive in a different region. And when you do that, you're going to see a similar effect. And this is actually, so there's been some response, well, wouldn't you expect this, especially if you're coming out of a patent literature? But there's actually a lot of arguments that you wouldn't expect this. That if science is non-rivalrous, that knowledge is free, there shouldn't be any localization of science knowledge. There's incentives, go back to the sociologist Merton, there's incentives there for science to get out. So we might expect no localization of science. And if you look at a lot of very careful econometric work by people I respect, Pierre, Waldinger, others, there's actually no effect of geography and distance in the diffusion of science knowledge. So we think this is still an open question, and when we do this, we see a very similar pattern, that you're going to see a localization of knowledge. And we looked at three different types of diffusion of science knowledge. We looked at science to science, and then science into medical organizations such as hospitals, and then science into technology, science into patenting. And you see localization of science to science, you see greater localization of science into medical application, and even greater localization of science into technology. So this is one reason I think we see it so often. We see our tech clusters, you see a correspondence, a correlation of the science research and tech clusters in the same place. And so this is one of the reasons that's happening. Okay, that's the regional economics papers. Now put your strategy hat on, and since we're in Hungary, let's put on the crown of Hungary, and let's talk about strategy now, and apply this model of regional economics to strategy. And this was recently, like just last week, accepted in management science. So micro foundations of absorbed capacity. So it's always good. One of the complaints about my work at Harvard was that you can't actually talk to managers. And so I'm always very pleased whenever I'm doing something that appears in the New York Times. Well, not this particular research, but it's a description of Apple and their watch. And they wanted to integrate a blood pulsimeter. So this looks at the oxygen level in your blood. This is not something that Apple has done. It's a very new technology for Apple. What they did is they first went and talked to a startup and tried to license that startup's technology. Negotiations didn't go very well. So then Apple set up a satellite right across the street from them. And guess what happened? They got sued for patent infringement. And so this is a precise example in the real world of what I think I'm going to show you. Okay, so we're going to talk about absorptive capacity, incredibly influential, and many citations. Bonus points here. How many sites are going to arrive in our half-hour seminar? Just it racks up more and more sites all the time. This is as of 2 years ago. So the problem, however, the literature, almost 100,000 papers now, literature hasn't made much cumulative progress. And it's gotten a lot of critiques. A lot of people have been very unhappy with it. And I think Anne-Marie Knott wrote the canonical critique. The original paper, the first 5-10 pages of the theory, I just eat that stuff up. It's wonderful. And then they go to R&D as a measure of absorptive capacity. And so a lot of critiques. And since then, we've had a lot of very good people making some very trenchant criticism of the literature. And it's just, when you look at it, there hasn't been much cumulative progress. You can pretty much, working with reviewers on this paper, boy, there's so many papers out there. You can pretty much get any result you want in the literature. So let's go back to its cognitive roots. And if you reread this paper, it's a staple on doctoral courses. The early part, the first few pages, are very much at the social, psychological, or psychological level. And so it's a very cognitive approach. And now we can also identify individuals and firms. So we can go to that cognitive approach. What we're going to do, there's so many mechanisms of absorbent capacity. We're going to focus very narrowly on one specific mechanism about interpersonal knowledge spillovers across firm boundaries. I'm going to ignore a bunch of other mechanisms. So you could have the ability to read the scientific literature. You could hire people and have mobility. Reverse engineering. My first job as a semiconductor engineer at Hewlett-Packard. That's where I met Candace. My first job at Hewlett-Packard was to pop open the lids on an Intel, an AMD, and National Semiconductor chip and measure the geometry of their technology. That's absorptive capacity. We're going to ignore all of that. We're going to look at the very narrow mechanism of interpersonal knowledge spillovers. Because remember, the source of knowledge, the exogenous source of knowledge we're going to turn off is a person. And the only thing we're going to change here is the presence of a person in a region. So that's the mechanism we're going to focus on. So again, we have these circles, these concentric circles. Previously, we were counting and comparing. I had 16 sites in Massachusetts and 30 sites in California. We compare those two counts with a Poisson model. Now we're going to move to look at every single citing inventor, not just all the patents, subsequent patents in each region, but every single inventor on those patents. And we're going to do a dyadic estimation of whether that inventor cites this patent as a function of someone being alive in the region and someone not being alive versus someone not being alive. Okay, so part of the problems for AC, for absorptive capacity, is the measures, and that's been a lot of the controversy. We're going to go back to the original. We're going to largely function at the firm's level of prior related knowledge. We're going to measure this. The absorptive capacity we're going to measure is of the citing inventor. Does he or she have experience in the technology of the deceased patent? That's going to be our measure of absorptive capacity. And again, when Wes and Dan Leventhal came up with this 35 years ago, we just didn't have these data. They could only think about firm level measures of the phenomenon. Okay, the second problem we would argue for absorptive capacity is causality. How do we run an experiment for absorptive capacity? So we're gonna decompose this problem. We're gonna measure the firm's deciding inventor and his or her firm's capacity before the death. And we're only gonna look at interpersonal knowledge spillovers, and then we're gonna exploit this death as an exogenous change in the knowledge that's possibly to be absorbed. Again, using this death and arguably randomly occurring. One of the ways we check this assumption, we take younger inventors, we split out younger versus older inventors. Older inventors are more likely people will assume or expect them not to be around. And then younger inventors, it's more typically going to be an unexpected car accident or something along those lines. Okay, this ended up giving us over 110 million observations. This is one of our co-authors, Sonia Look. She did all of the work. She's a staff professor at Paderborn. Just phenomenal effort on her part. Okay, so this is the basic knowledge, the basic check. We've flipped the axis, but the same idea. As you go further and further out, this is the benefit to being in California. We now have a positive benefit. We've moved to a dyadic 0-1. Does the potentially deciding inventor, cite the patent in California as opposed to Boston? So this is not a hypothesis, just this assures us that we've got the right model. So, okay, so going on to theory, again, very basic stuff. If you've got AC, you're more likely to take advantage of this interpersonal knowledge spillover. If firms who've got inventors with that similar background are more likely to be able to take advantage of it. Firms in California with background can take advantage of that still living source. Biotech is more likely to cite a biotech patent. Importantly, this effect, if we've got it right, should decline with distance if we've got this right. So how do we actually test that? So we're going to go to a dyadic model here. You have a citing inventor as the unit of analysis, and it's going to be a function of whether they're in California or Boston, and also a function of the experience. You know, are they a biotech inventor citing a biotech patent? And then the interaction. And I think that the most crucial test, and kudos to the reviewer, thank you if you're in the audience, who pushed us on this, show me this interaction declines with distance. So, good, okay, drama, okay. Okay, so this is the interaction, and indeed, that interaction term declines with distance. When we got this, we hoped the paper was still alive. And so you see this interaction, if you go back, this is the equation we're estimating. Are you in the region where somebody's still alive? Do you have experience? And then the interaction. Okay, the other beta coefficients there that we're estimating are also pretty interesting. I'm still wrapping my mind around this. This is actually pretty tricky. So this is measuring whether you have experience or you don't have experience. Independently, you still see a geographical localization there. It's good to be near the interpersonal knowledge spillovers. So that's an interesting result. This is even more interesting. So if you do have experience, you have to live, if you've got experience, you've got to live in California to take advantage of that. That's this flat line at the bottom here. So if you don't have experience, it's just not going to be helpful. If you have experience, you have to live locally. And here we go. And I find this very interesting. It's a question for for coffee afterwards. You know, there's 3 Marshallian spillovers. You see no localization here, and so I'm wondering, and Ben and I are arguing about this right now. You know, is this evidence that the second and third Marshallian mechanism aren't that important? That it's all knowledge spillovers? I don't know. So, okay. So we're going to go on with some interaction hypotheses, some more advanced, more interesting hypotheses here. The interaction, I think, is new. These linear hypotheses are not. Absorptive capacity should be greater when it's newer. You know, knowledge decays, routines weaken when they're not used. we're going to measure this as the time since the citing inventor patented in that field. And we indeed see that. It's a pretty straightforward hypothesis. It comes directly out of the original paper. So the more recently, we all forget stuff, especially if you're getting stuff now and I'm getting older, doesn't last very long, and that's what you would expect. Okay, so now that was the citing inventor, how recently he or she had experience. Now let's look at the knowledge itself to be transferred. And to what extent is an interpersonal source helpful when knowledge is transferred? And I think the meta argument here is that people are more useful when it's harder. So any kind of knowledge that is harder to transfer, it's more useful to have somebody there. And she can put an equation on the board, you can draw together. It's just, when it's hard to transfer, it's more useful to have that interpersonal source. And we're going to use multidisciplinary. A measure is going to be, is the original patent to be cited? Is it within one single discipline, or does it bridge multiple disciplines? And Tom Brokel, who I think is here, I haven't met him yet. Okay. So Tom gave me that as well. So okay, and the argument here, theoretically, if I do have a strong foundation in one field, I can learn more about another more easily. Whereas if I'm looking at two fields where I have no foundation, I'm really going to be sunk. So we're going to measure this as the number of technology classes. So I was going off the deep end. I read all of Tom's recent work, getting a really, really tough measure, a good measure of complexity. I gave up. My early measure of complexity is horrid. And so we just measured multiple disciplines as a measure of more complex and more difficult to transfer knowledge. And indeed, you see that. Okay, let's put those two together. So the absorption capacity is better if it's newer, plus it's more effective when it's difficult knowledge. You should see an interaction of these two. So recently created AC is going to be more helpful for the more difficult inventions. It's just an interaction. I love I love Jane Jacobs' work, and I think it's very consistent with her description. The micro geographies that Louisa talked about. You're just thinking of that street corner, the very cool hip place where all the young smart professionals are getting together and creating amazing stuff. So they're learning, they're innovating as they learn, and it's just this nice feedback loop. So we think this is a new prediction. Apologies to anybody in the audience who's made this prediction before. We scoured the literature. I used the latest AI models and was quite disappointed, although it was nice. One of the models gave me an extra management science paper, which I didn't even realize I published. So but we think that this is new. And please let me know before this is published if it's not. We'll give credit where it's due. And you do see, indeed, this very nice interaction. And this would appear to be driving the linear results. It's really, when you think about it, back to Jane Jacobs, it's the difficult new stuff that's best transferred by recently trained engineers and scientists. Okay, last hypothesis. We should see a weaker effect within firms. Currently, we're looking at a cross-firm, the technical knowledge spillover. We should not see as strong an effect within the firm. Huge amount of literature on this topic. Firms put a lot of effort into place to get that knowledge transferred across their employees within their firm boundaries. I won't go into this. It's consistent with Felix and Friends, their recent management science, where firms actually had not too much trouble reacting to the death of an inventor, but it was the outside firms that actually had more trouble. And so when you run this, remember we've got these concentric circles here. When you run this, you don't see much. Firms appear to be very effective at not localizing their knowledge spillovers. You can draw a flat line through all those numbers. Okay, every research has things you can make better. We're missing a lot of spillovers. It's a tough method empirically. To really make a causal claim here, we need a bunch more IVs for every single interaction. And then I think Francesco and others have done so nicely. I think a lot of this is social networks. Ben's a hardcore economist, and I've argued with him, you should go there, and he's like, ah. So, but I think a lot of it is the social networks here. So, okay, so to summarize what we've talked about, we took absorption capacity, we decomposed it, we focused on one narrow specific mechanism, we turned a source of interpersonal knowledge off using the unfortunate death of an inventor or a scientist, and we looked at some mechanisms here. Looks like it's the new absorption capacity and the more difficult knowledge that drive it. Within firm spillovers don't localize. And finally, I think to this crowd, I suspect you would agree. It's really, really important to have the science and technology done within your borders. And I think I cannot express strongly enough my disappointment with the recent policy changes in the United States. I just think we're taking two big shotguns and shooting ourselves in both feet. And we're not going to see this for many years, the harm that it's doing to our economies and our societies. Okay, shifting gears, this is the recent stuff. This is not that work, but this is a picture of people who both invent and publish science. We're calling them Pasteur Quadrant researchers. This data set is now available. This came out in Science a month or two ago. And this picture is a choropleth of where these people hang out. I suspect very few of you in this audience are surprised that they all hang out in a few places. Inventors are localized, inventors are localized, scientists are localized a little more, and these people are extremely localized. And these people come up with the best stuff and the most novel stuff on both sides. They're both more novel and higher impact on the technology, and similarly on the science at the same time. No causality here. But anyway, so moving into what I'll move into now is work with Gustavo Manso and again with Ben Baltzmeyer. And we're going to be building mainly on Enrico Moretti's 2021 AER. We're going to look at how do clusters influence innovation. I grew up in Silicon Valley. I don't know how many people know Silicon Valley until the 1960s was known as the fruit capital of the world. Plums and apricots and cherries, all sorts of wonderful, yummy stuff. But then stuff changed. And the semiconductors and these two guys in personal computers and then I guess big data and search. And now, surprisingly, I started my life as a semiconductor engineer, and I said, software is taking over the world. Now, if I'd stayed in that field, we'd be back at hardware again with NVIDIA's processors and powering the AI revolution. I think another question that's interesting is, how has Silicon Valley managed to do this? No answers there yet, but if you've got an answer, I'd be very curious. So going back to Marshall, clusters benefit innovation. The three Marshallian mechanisms here, the co-location of the specialized assets, the pooled labor markets, and again, those knowledge spillovers. And building on Enrico's paper, 2021, I know it's been criticized, inventors, and he claims, and I think he's got it right, we're going to show a nuance here though, inventors will be more productive when they live in places like Silicon Valley. And the thing about this is, if you take this to an extreme, we should all move to Silicon Valley. Please don't. The traffic is already pretty bad. But if you take this argument to that extreme, that's where we end up. Unfortunately, I think we're going to have some results that that's not where we should go. Okay, clustering may actually distort innovation. And as the size of your cluster increases, each of these mechanisms can encourage the inventor to stay in their field. As the spillovers, as you hear more and more about your own field in the coffee shop, you're likely to stay in that field. You're not likely to go into a different field. As the infrastructure to support your inventive processes gets cheaper and more available around you, you're going to stay in your field. And finally, I think this is actually key. When it's easier to get a job by staying a job outside of your current employer, you're likely to stay in that field. Okay, so I'm going to skip the informal model here. Sorry, Gustavo, it's very nice. I recommend it to you. We're going to reproduce Enrico's result. We're going to decompose those results into, we're going to show that Enrico's results are driven by exploitation. Exploration actually goes down. And then we're going to actually look at the value of the resulting patents. And then we're going to we're working on some refinements as well at this point. So model intuition, I'm gonna skip Gustavo's model. The individual inventor chooses. She chooses to either explore or exploit. And we're going to assume that an exploitation strategy is more likely to succeed, but it's less valuable when it does. And then it's going to yield a patent with a certain parameter, certain value and probability. The exploration strategy is less likely to succeed, but when it does, it's going to be more valuable. This is pretty straightforward stuff. But it's nice to have a model with it there. And it's consistent with a lot of with Gustavo's dissertation and early work and a lot of empirics. Okay, so and Gustavo comes up with 3 propositions here. Productivity, if you're just going to measure the number of patents coming out of a cluster, is going to increase with cluster size at a greater than linear rate. Secondly, this is going to be driven by exploitation patents. The exploitation patents are going to go up as the cluster gets bigger. The exploration patents are going to go down. And finally, the value of these patents are going to decrease with the cluster size. The average value of patents will decrease with cluster size. Okay, so empirics, we're going to use US data from Patent View, certain years, and we've got a larger data set than Enrico has, and we also, the results hold for stars and non-stars. He just looked at stars. For the field, we're going to look at the CPC class, the European classifications, take a set of cuts that the results hold. A city is going to be a commuting zone, and then a tech cluster is going to be the number of inventors within the inventor's field and city. So either the nine CPC classes or a couple levels down, the results hold. So we're going to exclude the focal inventor. And what I find, and this really has messed with my priors, we're simply measuring if you're a semiconductor inventor in Silicon Valley, how many other semiconductor inventors in Silicon Valley there are. We're not measuring biotech or energy or any other technology. You would think, again, as a fan of Jane Jacobs, that it was the diversity that should be driving the exploration. We're not going to go there, and we're still going to see a very stark result. And dependent variables, so we're going to look at the productivity, individual inventor productivity. We're also going to, like, if there's 3 people on your patent, you're going to get a third. And this is eventually granted patents. What we're going to do, and the results are quite stark, we're going to split those patents into known exploitation patents. And that measure is whether the inventor has previously patented recently in that class, or does that inventor, does she explore? Does she go out into a new class she's never patented in before? And we're also going to just look at the fraction. What fraction of the patents is she inventing in her known areas versus her new? And that will also hold up. Okay, dependent measure of outcome. There's a new QJE out, Josh Lutter and a young guy, Kalyani, QJE. This is worth reading. It's a very biased measure, in my opinion. They do a very nice job, lots of machine learning, of getting just the really valuable, commercially valuable patents. And so we're going to use that as a measure of financial outcome. It's far better than KPSS. We're also going to use KPSS. And then we're just going to go into the old standby and most used measure in our literature, that is citations. So the search outcomes, exploration versus exploitation. We're going to confirm Enrico's results here. Simply as a function of cluster size, you're going to see an increase in individual creativity. However, this effect is driven entirely by exploitation. If you look at, so the original results on this is the 0.010, you break that out, patents in known technology is much stronger. Patents in new technologies, the exploitation is much more negative. And so Enrico's result appears to be entirely driven by exploitation, or not by exploration. And he's got an IV. We're trying to improve upon that right now. But if you run Enrico's IV, the results hold, stay very strong. Okay, now looking at the financial outcomes. Take the Kalyani measure, the average value goes down as the cluster gets bigger, the average number of citations goes down as the cluster gets bigger, and also the KPSS, the stock outcome, the stock price outcome goes down. And these results mostly hold up with Enrico's ID. The success isn't significant. Okay, so do we want, traffic aside, please visit, but please don't live there. Traffic aside, do we want all the inventors in Silicon Valley? Probably we don't. I attended Ron's talk yesterday about policies. We should be pretty smart on the sorts of policy implications that we might pull out of these results. There's a lot of different things you might do here. Maybe we just need more collaboration across clusters, and we should just subsidize inventors to hop on airplanes. I don't know. So, which Marshallian mechanism drives this? I don't know, and I think that's a great question for future work. And then, where is the optimal point here? That's also a question for future work. And these results are about 3 months old, so they're pretty new. So the takeaway for the second stream, this is the Apple ring, and this is Detroit in a not wonderful time. Do we want to have everybody living in Silicon Valley? Probably not. It doesn't appear that clustering provides monotonically improving benefits. So with that, in a few minutes.
Thank you so much. Thanks, Anita. That was fascinating. Thanks for taking us on this journey through your recent work, actually. I'm sure there are a couple of questions. As promised, I will start here. So if you have a question, please raise your hand or even stand up. So here's one in the front. Here in the front. For Ron, exactly. Yeah.
All right. Thanks a lot. It was a very fascinating talk. I really enjoyed it. I was just wondering about one of your outcomes, right? That you are new, that they're going into new patterns or they stay within the same CPC class. I mean, it's a bit black and white, right? So could there not be a combination of the two? I mean, do you exclude that, or so how do you treat that? Because I guess that if you go to new patterns, you also might stay in the same pattern class at the same time.
You stay. It's very black and white. There's a new one. We should.
Even if you stay also in the same pattern class.
Multiple classes, yes. So I need checking.
Yeah.
All right, thanks a lot. That was a quick answer, everyone. More questions. Please raise your hand, stand up. Oh, yeah. Close.
So I absolutely love these papers, and the new one's really exciting to see. I was thinking also, of course, that if cluster size is decreasing the cost of search, you would expect an increase in the quantity of publications or patents and a decrease in the average value, exactly what you're picking up. But I think a very quick first test would be to see if the total value of the bucket of patents produced by the inventor declines also.
Exactly. Yeah. And Chris and I live about 10 miles apart. We have to travel all the way around the world to talk. Chris and I live about 10 miles apart, or 15 kilometers apart, so we have to go to Budapest to talk. So. Coffee?
This was fascinating. Thank you very much. I was wondering, the inventors that died. You think of them as sort of vessels of knowledge, but they may be creating sort of an ecosystem. So if a senior researcher would die, a lot of stuff, more than just a knowledge, would be done. So the future impetus for work would also be harder evaluations. Doesn't contradict what you're saying? But
No, I that's one of the mechanisms we would actually say is driving this. Absolutely. So we don't see a difference with age, etc. This appears to be across ages and stature. Pierre's data set is all very, very big people, exactly the sort of people you'd be describing. Howard Hughes, investigator, award winners, etc. So,
One more in the back.
I'm not room enough.
You need to wear helmets in these sessions, okay?
Thanks for the presentation. I wondered if you look at different types of regions. So, for instance, in the US, and this patenting is very, very clustered in space, where maybe in Germany or in Sweden it's more distributed, and it's like more in peripheral regions and maybe not the big city regions. Did you look a little bit at different types of regions?
So the first stream, we're trying to wash that out. You have to assume that death's random, and it's going to happen across regions, not as a function of region. That's one of the assumptions of the approach. The second stream of work, no, we haven't, and that's a great direction to go in. Absolutely. Thank you. Yeah.
One here and one in the back, and then we have to keep.
Thanks a lot for a fascinating talk. A quick idea I had while listening to you is a little bit related to the point I made yesterday. So these inventors that die, they usually don't operate in isolation, as essentially Frank was mentioning, but they also hold different positions in their respective knowledge networks, right? So one would assume that the effect is probably stronger for those that are a little bit more central in these either local or generally knowledge networks. I think that could easily be tested.
I totally agree. Can you talk to Ben for me? We've had this argument, and I wanted to go there.
Thank you. I really like how clearly you explained the concepts, and also I like the way you connected the examples to real life cases. And it's possible I missed some of the things in the variables and the explanations. I wonder if you consider also external factors, such as, I don't know, like environment, local and historical context in your variables in the equation.
So that we don't, and the beauty of Ben's identification here is that shouldn't matter. You have to think hard about it, and you have to buy the assumptions, and we lay those out in the paper. But if you buy the identification, those things shouldn't matter. If you believe that death is random, and it's you're no more likely to die in one region or the other, which you could question this, then that shouldn't matter, at least with the first stream. So we go into great gory detail. That obviously was a very difficult question to get past the review.
All right. Thank you so much. Thanks for both.